How's it going? Cup of Science Joe here. You can see that I am not in my usual spot. I certainly don't live here. This is a condo I am renting in Florida. Why is Joe in Florida, you might ask? And the reason is because tomorrow I am going to get to see a rocket launch. My first ever rocket launch in person. I was able to get a ticket to go to the viewing site. This is going to be Launch Complex 39 at Cape Canaveral. And I'm super excited. So, the, the first thing I'm going to put out is that because this is my first launch, I'm not even going to bring my camera. I mean, I'll have my phone so I can take pictures of the launch vehicle before it goes off and take pictures and maybe some video of where I'm at. But I really want to try to avoid attempting to record or photograph the launch itself because I don't want to miss it. It's my first one. It certainly won't be my last one. I'll have plenty of opportunities in the future to attempt to photograph launches. It's not going to happen this time. But what I did want to do was make kind of a two-part video that I will put together in the end. This first segment, I'm actually going to talk a little bit about the spacecraft that are going to be launched. It's the IMAP mission, and there's two other spacecraft that's with it. That's going to be this part right here. And then tomorrow or Thursday, depending on my schedule, but a day or so, the day of or the day after the launch, I will do another part where it's just me, maybe sharing some pictures that I took and talking about my experience with the launch. So, with that little bit of groundwork here, let's get into it. I've got some notes. You might see me look down. So, we have, this is going to be flying on a Falcon 9 rocket, like I said earlier, from Launch Complex 39A to be exact, from NASA's Kennedy Space Center in Cape Canaveral, Florida. And we have those three satellites. Two are from NASA, IMAP, and the Carruthers Geocorona Observatory. And one is from the NOAA, the National Oceanic and Atmosphere Administration. That is SWIFO L1. So let's touch a little bit on what each of these are and what they do. Starting with IMAP, which stands for the Interstellar Mapping and Acceleration Probe. And this mission is all about the heliosphere. But you might be asking, man on the internet, what even is the heliosphere? And while this may warrant an entire video on its own, possibly even in tandem with IMAP once it's actually up and running and has collected some more data, let's touch a little bit on the heliosphere here. And I actually have a little promotional handout that NASA gave to all of us going to see the launch. So, from hearing Helios, you may already be guessing that it has to do with the sun. You just saw that there. And to take it one step farther, we can kind of describe the heliosphere as the area of influence of our sun. This includes its magnetosphere, astrosphere, all the way out to the outermost layers of its atmosphere. And if we come back up here, you can kind of see, I'm not sure how well the camera's going to pick it up, all the way out here is the heliosphere, out to the heliopause. And it takes the shape of an elongated bubble or sphere, and it is constantly filled with the solar wind. In many ways, it protects our solar system from the large amounts of cosmic radiation that are coming in from interstellar space. Now, for everything we do know about the heliosphere, like many things in space, there is so much that we don't know. And this is where IMAP comes in. It's going to be stationed at L1, Lagrange point 1, and we're going to touch on Lagrange points later. And it's going to help us further map out the heliosphere and how it interacts with that incoming material from interstellar space. that I mentioned earlier. It's going to study both particles that have come from the sun that are filling the heliosphere, and it's also going to cover particles that are coming towards the sun from interstellar space. The heliosphere extends out somewhere between 6 to 9 billion miles, so it's pretty big, right? The influence of the sun is big, we know, and its influence is even bigger. And then IMAP's even going to be able to study stuff that's beyond that, like remnants of exploded stars that are beyond our solar system. I mentioned this earlier, like the heliosphere and probably IMAP, I think I will give it a more in-depth video of its own once it's done some science and we have some more data from it and it's taught us some new things. I do think at some point in the future that would be very cool for a video of its own. And so I mentioned 2 other missions that will launch with IMAP as well, and let's go ahead and go over those too. Which brings us to the Carruthers Geocorona Observatory. This satellite will be studying mostly the Earth, but namely its exosphere, which is the outermost layer of its atmosphere, helping us to learn things like its origin, how it has evolved over time. Found at the exosphere is a transition region of sorts between Earth's environment and the environment of space. This region is not abrupt, though. It's not like you just cross over and then you're on to the other side. It really kind of spans thousands of kilometers. So even in its own right, it's a pretty big space. And it is rather tricky to observe the exosphere from Earth. The first time it was imaged was actually from the moon during the Apollo missions. I'll probably put up a picture of that on the screen. And even then, they weren't able to get the entirety of the exosphere because we were not far away enough. So the moon's like 238,000 miles away, 250,000 miles away, somewhere in there. Lagrange point 1, where the satellite is going to be, is about 1 million miles away. Roughly the same distance that JWST is at Lagrange point 2. And so we're going to have way more distance to look back and view the Earth's exosphere with. It's going to help us study things like how Earth responds to space weather, primarily coming from the sun, and the fundamental physics of our atmosphere. The third satellite is called SWIFO-L1, SWFO, or Space Weather Follow on Lagrange 1. So it, with the other 2, all of these are being launched out to Lagrange point 1. And this one has a couple of functions. It's mostly centered around helping us study weather, space weather coming from the sun. It will have a special solar telescope called a coronagraph to help monitor the sun's activity and its corona. And then it will also have a suite of instruments, I actually think there's 2 of them, that will be used to take measurements of the solar wind. This is going to help us prepare ourselves for weather events that come from the sun. One such example of this is solar flares. These events can damage things like spacecraft in orbit or pose risk to the astronauts aboard, things like the ISS. They can damage GPS and communication systems. They can damage our power grids down here on Earth. So it's nice to have a modern way of studying these, because some of the satellites we have studying it right now, they're starting to age out, like reach the end of their missions. SWIFO is going to help us study these, take these measurements in 2 different ways. It has that coronagraph I mentioned that will actually be able to take images of things going on in and around the sun. But also, so we'll cover this next when we go to Lagrange points, but L1 is between the sun and the Earth. I'll find a picture. I'll put up a picture of the Lagrange points. But for SWIFO, when it observes, say, a solar flare, it's going to see it, And then a few days after, like between 36 and 72 hours-ish, that solar flare is going to pass by the satellite, basically hitting it. And then the other two instruments it has on board are going to be able to collect data about that flare and relay it back to ground teams on Earth, telling us about how severe it is, giving us information about things we can do to help prepare for it. There won't be a ton of time between when it hits SWIFO and when it hits Earth, I think maybe around an hour. But it will be enough time for response teams on the ground to make some preparations to protect things or people, both in space and on Earth. So it's kind of nice that it can image something, we know it's coming. Once it hits the satellite, we learn more about it, and then it helps us make preparations for when that solar flare is going to hit. And so to end off this little segment here, let's talk about these Lagrange points that I've been mentioning. The first three, L1, 2, and 3, were discovered by Swiss mathematician Leonhard Euler, I probably butchered that, around 1750. The remaining two were discovered a decade later by Italian-French mathematician Joseph Louis Lagrange. Another Joseph, like me. Lagrange is what we call them, so they were named after him, Lagrange points. These 5 special points are spots where a small mass can orbit in a constant pattern with 2 larger masses. I may actually take some JWST examples to show kind of what this looks like. There's a little animation that shows it. It's at Lagrange 2, which is on the other side of the Earth. And then we can pair that with maybe an image of L1, which is between the Earth and the Sun, where these 3 satellites are going to be. These points, this is possible because the gravitational pull of both larger masses are equal to the centripetal force required for the small object to move within them. So you get kind of this balancing feature. Of these 5 points, 2 are stable, L4 and 5. They're like leading and trailing the Earth. And then the other 3, Ls 1, 2, and 3, are not stable. They're kind of on... L2 is on the outside of the Earth. So Earth, Sun... I'll probably put a picture up. L2's here. L3 is between them. Or L1 is between them. And then L3 is like on the other side of the Sun from the Earth. Those are not stable, which means that... So in L4 and 5, like, asteroids can collect there. Like, if asteroids get captured in L4 and 5, they just kind of chill. An example of this with Jupiter is the Trojan asteroids. There's a group of them leading Jupiter, and there's a group of them trailing Jupiter. They're like trapped there stably. Those are in the Lagrange points. For Jupiter, Earth quite possibly has something similar. For Ls 1, 2, and 3, you can place stuff there, but they will eventually decay out of those orbits. So for our spacecraft, they need to have thrusters on board and enough fuel to push themselves back to keep themselves in that orbit for the duration of their mission runtime. And so there we go. That's a quick overview on the 3 missions being launched. There's a good chance I go more into detail with these later, but I wanted to keep it somewhat simple for this one. And when you see the next part of this, it's going to be future Joe, a couple days from now, talking mostly about his or my experience getting to see up close and personal, at least as close as they'll let us get, my first ever rocket launch. So let's see how that goes. It's around 3:20 a.m. Yeah, I got my coffee. I'm kitted out. I got my NASA shirt. I need my space. It's very Joe coded. And I even got a little sling back here with my stuff in it. It's ready to go. We need to leave around 4 to be able to get to the Space Center within the window of time to get shuttled out to the launch site. So, I'm not sure where in the video I'll put this. I did my little thing yesterday where I was like, whoosh, whoosh. Only to realize that this morning I was going to do this and then not do that part. So maybe I'll still incorporate that with the actual part of this I record when it's time to go to the launch. My hair's not been brushed yet. But yeah, I am definitely excited, dedicated to the cause, and we're gonna see just how this goes. How's it going? I'm back. Cup of Science Joe, and this is actually the day after the launch. I got to see another launch this morning, but from the beach, so it wasn't nearly as close as the last time. And I wanted to, I thought it might be kind of fun, right? Record the first part the day before the launch, record the second part the day after the launch, and that gives me a little bit of time to kind of think about what I want to say and compose my thoughts, if you will. I wanted to leave this open so you could see outside, but it is way too bright for me to sit in this spot. My camera was not happy with it, so we're going with this. We're going with it closed this time. So yeah, so rockets are like, I mean, okay, so I'm more in the science and the astronomy side of things and less into the rocket side of things. But I do have to say that rockets are still super cool, so powerful, so much oomph, so much power. And I really have like even more of an appreciation for them than I did before, right? Because when you look at all of our space missions, anything going to Mars, any satellite that's in orbit at all, everything we've sent to the outer solar system, even the Voyager missions that have kind of left the solar system, all of those are only possible because we have rockets that can put them up there. So the rocket side of it, it is absolutely integral to the success of the science side of it. And obviously, like, you hear that it's not rocket science. Well, this time it actually is. It is rocket science. So now I want to talk a little bit about my experience in general going there. So you'll have seen I woke up at 3 a.m. Now, I am a bona fide morning person. I have been my whole life. But 3 a.m. is still really early. We needed to leave the condo by 4 in order to get to Kennedy Space Center in time to be one of the groups that was shuttled from the main visitor area out to where the launch complex is. So this one came off of Launch Complex 39A. Yeah, we were in what is called the Banana Creek launch viewing area. So I think we were right around 3 miles away from the rocket. That's kind of like the safe distance that they can let people be at. I was not going to record this at all, but I ended up getting my phone out. Like, the main thing I wanted to avoid was taking my camera, taking extra lenses, trying to mess with the setup, trying to mess with framing the shot, and then the rocket launches and I missed both things. I missed the video, I missed the photos, I missed the launch. That's what I was trying to avoid. But right when it was about to happen, I'm like, I should try to get something. So I just took my phone out, I had it like this, and I didn't really look at my phone. I think given how little attention I paid to it, I actually got like pretty decent footage, which I'll probably have up while I'm talking about it. And I just kind of tracked my phone with me for the most part as the rocket went up. So I was able to capture something to remember by, something to show that I actually did get to see this. But I also did so without compromising my actual viewing experience. So once we got to the launch viewing site, we got there pretty early, so there was a lot of seats available. We went to the bleachers. We found a section near the co-workers of my brother-in-law. They all worked predominantly on SWIFO, which was one of the 3 satellites we talked about earlier, but they also did some work on Carruthers, the Carruthers Geocorona, one of the 2, Observatory. But SWIFO was their main one. And so one of the first things I thought was cool about being in the launch viewing area, because this was the main viewing area for everyone. Public who could buy the tickets, which they were on sale, and then also for the teams that worked on the satellites. So it was really a cool experience to get to just hear different people talking about the different projects that they worked on. And we were all there in one spot, right? Like, I'm like, here's me, just some random man on the internet who talks about these things, surrounded by a lot of people who do it professionally, engineers, scientists, even photographers taking, pictures of the launch itself, although some of them I think probably are at the amateur level. But it was really fun to just be there, right, and be a part of that, and just hear so much excitement coming from those around me for different things, for whatever their part, whatever they were there for, Mostly I heard about SWIFO because that's the area that I was in, but it was really cool. Obviously, when you have that many people around, you really want the launch to go off without a hitch. It being scrubbed is not what you want, but it is worth it if it saves the equipment. And you certainly don't want anything to go wrong. So in this case, there was no scrub. I mean, it did get pushed from Tuesday to Wednesday, but I had known that pretty early on. There was no scrub on Wednesday. The launch went off. Everything went smoothly. Later that afternoon, all 3 satellites were released from the fairing and are now on their way to L1. So everything so far is looking good. Obviously, we won't know that the satellites and their instruments are all working until they're all tested and they actually get into their orbits and we become able to start collecting data and doing science. But at the very least, the launch was smooth. All the satellites got released. Everything's on its way. Yeah, but going back to the launch, right? It's pretty cool. We were there for about 2 hours, an hour and a half to 2 hours before the launch. And there was an announcer, an MC, if you will, and he kind of like talked about the missions, at least what he knew about them. He talked about how the launch was going to go. There was a SpaceX live stream that we had on too once it started, because SpaceX streams a lot of their rocket launches. So he kind of gave us an idea what to look out for. You have to pass certain checkpoints in preparing for the launch process, and that's pretty close to when it starts. So they don't fuel it until pretty close to the launch. And then once it's fueled, they have other checks you have to get through. And so if any of those checks fail, that's what can lead to a scrub. So he told us what to listen to on the video, when things were happening, what to look out for. That was a nice lead along, right? To have more of an idea of what was going on. And so there was also a Apollo building, like all about the Apollo programs. There was a Saturn V rocket in there, which I have pictures of. I'll put that up on screen. And I spent about an hour touring that before the launch. There were a couple of videos. One was about kind of the introduction to the American space program, starting from when the Russians launched Sputnik. At the time, the Soviet Union launched Sputnik, which really kicked us off into the space race. And then the second little video presentation was all about the Apollo missions And I think it actually centered mostly on 11 and 13. It wasn't all the Apollo missions. But it did talk about some of the struggles that astronauts ran into during some of those missions, and like just how big of a deal it was that we actually pulled them off. And then there was a bunch of just other exhibits in relation to the Apollo missions. Let me see if I can find some good ones. There was a moon rock. I got to touch a moon rock. I'll put that on screen. They had a lot of the astronaut suits of the past in there. They had some replicas of the lunar modules that astronauts stayed in. They had the lunar rover that was driven on the moon. So it was really cool. It was a nice intro to the, to the Apollo program in general. And it's especially cool for me because one of the telescopes at the observatory I volunteer for was part of the Apollo program. It was commissioned by NASA to study the moon and help find landing zones for these very Apollo missions that I was learning about in that building. So, and that was right next to the viewing area that I was in. So, once we got closer to the launch, though, I returned to my seat. He gave the final information on, like, everyone had to be sitting. They didn't want anyone standing up and blocking people behind you. There were certain areas that were reserved for evacuation, so we had to stay clear of those during the actual launch itself. And then we entered the final few minutes. Now, the countdown was on the video, which was delayed from what we were seeing in person. So the actual rocket launching did not line up with the countdown in the video, because for us it was real time. There was no delay. But as it got closer, I could feel the tension, right? You got all these people around you who have poured hours and hours and months and years of their lives into the payloads that are in the fairing on that rocket. And here we are, minutes before the launch. Of course, everyone wants it to be successful. Everyone wants it to go off without a hitch. And you can feel that. You can really feel that in the air. And the chattering kind of did die down a little bit. It got quiet leading up into the final few seconds. And when the rocket actually launched, it was pretty cool. When it's ascending, it doesn't look like it's going super fast. There might be telemetry data that I can look up for this. I'm not really sure how fast the rocket is actually moving when it leaves the pad. But the nice thing about that is you get a decent amount of time to watch it going up and up and up. And then eventually it curves as it starts to get into its trajectory, to insert the satellites into an Earth orbit before they get kicked off. This was a Falcon 9 rocket, so the first stage did separate and then come back and land on a barge. It was about 400 miles away, so we didn't get to see that. But the first stage did come back. And there were some cool effects. It was loud. It wasn't tremendously loud. I think that a big part of that is just because we were still 3 miles away. So there was a good bit of distance the sound had to travel. But you get a delay. You can see the rocket going up right away, of course, because the light reaches you almost instantly. But there was a good 10 or maybe 15 seconds, if I was to guess. There's no math behind this. This is purely a guess. Before the sound of the rocket reached us, and you really hear the booming and see it go, or hear the effects of what you were watching. And so there was some cool effects, though. As it gets into the air, it casts a shadow, and I have pictures of this, a long, thin shadow all the way across the sky, which is probably the most interesting and almost weirdest shadow experience I've ever seen, except for maybe during an eclipse. When I saw the total eclipse, there were some crazy shadows there too. But yeah, you just have this strip this shadow strip from the rocket going across the sky. That does eventually go away once it moves out of the path of the sun's light, though, at least in terms of the angle we were at. And overall, I was very excited about this. This trip was worth it. All the early mornings were worth it. The money I've had to stay to come here was worth it. This is definitely not the last rocket launch I'm going to see in my life. This is certainly something I'd like to do more of. And I really like this format where I talk about the stuff being launched, and then I talk a little bit about the launch itself as well. So if you're into science like me, if you're into astronomy, but especially if you're into rockets, I implore you to see a rocket launch if you haven't already. And it's fun watching them from a distance. I'll talk about a little bit about that next from this morning. But the real experience came from actually getting a ticket and going to the launch area and being a part of that experience with everyone else there, either public or the people who worked on the spacecraft, which they're still part of the public for the ones I think we can go to. But you know, for them it's a little different. They've been working on this for so long. It really is a wonderful experience. So this morning, I got to see an Atlas V rocket launch. So this is a ULA, United Launch Alliance spacecraft. It is expendable, so it doesn't return like anything SpaceX has. But it really looked different, like the plume. And I'll put a picture or something of this up, but the plume behind the Atlas V rocket is way thicker, way more visible than the Falcon 9 was. And I do wonder if that has anything to do with the SRBs, the solid rocket boosters that are a part of the Atlas V design. But that one, you couldn't see the shadow either. At least I didn't. I don't think we were in the right spot for it, like when you're actually close in the viewing section. But yeah, watch that go up. The plume lasted all the way until it reached a certain point in the sky. So you saw it all the way up. And that one was even quieter, but again, we were farther away. We were a lot more than 3 miles. I just walked outside the condo and went over to the beach and looked that way. And I was able to see it. So that was exciting, though. If I had gotten more launches from the beach while I was here, I definitely would have tried photographing some of them. But with only one example to go off, I didn't even really know where it was going to come from. It would have been super hard to frame a shot. So this time around, I just used my phone and did easier stuff because, again, like yesterday, I really wanted to see the rocket launch itself. And then to cap this off, Kennedy Space Center is really fun too. I was like a kid in a damn candy store at Kennedy Space Center. They have an IMAX theater. We watched a video that was all about JWST, the James Webb Space Telescope. They did have another one though, so you have a couple 40-minute movies. There's lots of exhibits. A lot of the exhibits are indoor as well. So even though it was getting hot in the afternoon, because we were doing so much stuff inside, it was relatively comfortable. It was more friendly for kids. My 13-month-old niece was there, and she was a trooper. But a big part of why she did so well, I think, is because we got to spend a good amount of time inside. They have a Mars theme exhibit. They have a Gateway themed exhibit that also talks all about the Artemis program. And you can see the launch capsules. You can see some of the spacesuits that might be used for Artemis. And that room even had different, like, an exhibit that showed off different spacecraft throughout history. And you could read about each one when you clicked on it. It was really cool. There were areas that we didn't have time to go to either. There was like an astronaut training experience, which I think would be really great for kids, especially kids who have an interest in this. That might give them an idea of what they would actually possibly be doing. You know, you could get photos with an astronaut. I'll put mine up on the screen. I have my thumbs up. I got my photos with at least someone in an astronaut suit. And there were tours. There was a bus tour we went on. It took us to a gantry for one of the launch complexes. I'll have some pictures of that too. We could see different ones out in the distance. I think there's 39, 40, and 41. And, you know, they had some examples of rocket boosters and how they work. It was super cool. I would certainly recommend it. I think it's great for adults and kids. And even members of my family who aren't me or my brother-in-law, who aren't as interested in this sort of thing, they had fun with it too. So it was totally worth it. It's nice that when you buy a launch ticket, it comes with the day pass for the Kennedy Space Center as well. So you get to do both. You can see a launch and then you can check out the center with the same amount of money that you spent for that. And there are other tours as well. There was one thing I saw online where you can sign up to meet and chat with an astronaut. I think it's like a group setting, and then you can meet with an actual astronaut. That's something I'd love to come back and do in the future. I would say that you need more than one day. I only had one day, including the launch, and we did not make it through the whole day because of how early we started. By the middle of the afternoon, we were all thoroughly cooked, and so we returned back. So if I'd had more time here, I would have maybe planned for 2 full days. But yeah, you know, it's a lot of fun. I'll try to sprinkle pictures in with this. This is not scripted at all. I didn't write anything out for this second part. Maybe I will make a follow-up to this where I do more research and more writing and am a little more prepared. But this one I really just wanted to like sit down and simply just get my feelings out about this and express that I think this is something everyone should try. See a rocket launch at least once in your life. They're so frequent these days that it seems pretty accessible for everyone to get to see one. And SpaceX does launches out of California and Florida, so there's something for either end of the United States, if that's where you happen to live. And yeah, I will definitely be at least paying more attention to the rocket sides of things. Will I end up covering more on this channel? I'm not sure. Maybe if I start running out of things I want to talk about for the science and the astronomy side, I'll start trying to delve a little bit into the rocket side. But at the very least, this has gotten me a little more interested in it, and it's something that I want to pay more attention to. So I'm leaving on Saturday. I probably won't get to put this video together until I'm back on Sunday. Even if I try to do it here, I don't think the internet's good enough for me to upload it. But this will definitely come out, hopefully by next week. I'll have this together. We'll see how the footage looks. I know it's kind of bright in here, but I'm not looking for it to be super professional, so I think it'll be good. And with that, I implore you, let us all step outside tonight and look towards the stars.